So hello guys, welcome to Metabolism Wala NEET YouTube channel. So today we will start with dimensional analysis. This is a continuation of NCERT Physics Simplified. So if you don't know this concept, then you will have great problem in learning that chapter. Okay, let's start. Introduction. Dimensional analysis can be done in very easy steps. Step 1. Be well versed with all formulae. For that, memorize all formulae, which is a daunting task. So either you can choose any of these formulae. Complete your course and then touch units and dimension. Or learn the dimension of basic formulae and then move on. And then come back later on. I had used this second technique, but you can also use this first technique. So let's start. Step 2. Learn the basic dimensions. That is the dimension of SI units. Like length is capital L, mass is capital M, time is capital T, current is capital A, and temperature is capital K. Step 3. Start playing with this dimension. Let's play with this dimension. So here we have given the dimension of velocity, L to the power 1, T to the power minus 1. Since velocity is distance divided by time. Next, momentum. Momentum is mass into velocity. So m to the power 1, L to the power 1, T to the power minus 1. Acceleration is mass independent. So m to the power 0, L to the power 1 and T to the power minus 2. Since it is delta V upon delta T. Force is not mass independent. It is the mass times that of acceleration. So m to the power 1, L to the power 1, T to the power minus 2. Work or energy. Work or energy is force into distance moved. So m to the power 1, L to the power 2 and T to the power minus 2. Power is work done per unit time. So it will be m to the power 1, L to the power 2, T to the power minus 3. Spring constant K. K is F by X. So it will be m to the power 1, L to the power 0 and T to the power minus 2. So all these dimension done. Notice the chapter wise changes. Like in rotational motion. In rotational motion, the angular motion is taken into consideration. So you have to divide the same translation motion with length or use the concept of mass, which is equivalent to moment of inertia. So let's see. Omega or angular velocity, which is equal to V by R. So it will be m to the power 0, L to the power 0, T to the power minus 1, which is also the dimension of frequency. Next, angular acceleration alpha. Alpha is acceleration by r or radius. So it will be m to the power 0, L to the power 0, T to the power minus 2. Next, moment of inertia. Moment of inertia I is ml square. M to the power 1, L to the power 2. Next, angular momentum. Angular momentum is I omega. So m to the power 1, L to the power 2 and T to the power minus 1. In angular momentum, you can also use the formula mvr equals to angular momentum L. Okay. In torque, it is denoted by tau and it is I alpha. So m to the power 1, L to the power 2 and T to the power minus 2. And you can derive this torque from force into radius. So it is the same dimension as compared to work slash energy. Okay. Next, gravitation. Gravitation, if gravitation or gravitational force From gravitational force, we can find out the dimension of gravitational constant G equals to F r square upon capital M into small m. F is m L t to the power minus 2. L, here we have to put the dimension of r square, L square, and here will be m square, which comes out to be m to the power minus 1, L to the power 3, and t to the power minus 2. Okay, yes. And next, gravitational intensity G or capital E, which is nothing but force by mass, which has the dimension of acceleration. Let's find out that m to the power 1, L to the power 1, t to the power minus 2 divided by m to the power 1 gives out m to the power 0, L to the power 1, t to the power minus 2. Done. Next, gravitational potential U, which is the integration of E into dr, which is also the same dimension of gravitational potential in a, which is equal to m to the power 0, L to the power 2, and t to the power minus 2, since it is E dot dr, right? Next, a small request: if you are getting any help from this video, please consider subscribing for more such content. In solids, area has a dimension of L square, pressure has the dimension of F by A, that is m to the power 1, L to the power minus 1, t to the power minus 2. Okay, next, this dimension of pressure is equal to the dimension of Young's modulus stress divided by strain, which is equal to the dimension of bulk modulus, which is equal to the dimension of shear modulus, which is equal to the dimension of stress. Okay, next, fluids, volume dimension is L cube, density, the dimension is m to the power 1, L to the power minus 3, t to the power 0. Next, T is the surface tension is F by 2L, or in some places F by L, and in some places F by 4L, but that does not matter to us because these 4 to all are dimensionless. See, m L t to the power minus 2 divided by L gives out m to the power 1, L to the power 0, t to the power minus 2. Okay, next, moving on. Coefficient of viscosity. Viscous force is 6 pi eta rv, and use this formula to derive the coefficient of viscosity. Always try to derive the dimension. Do not ever memorize the dimensions. Okay, and after NEET 2023 I will prove it that how much these sessions will be important for you. Next, so eta will be Fv divided by 6 pi Rv. So the dimension of eta will be m L t to the power minus 2 divided by L and L to the power minus 1. So this L goes with this L will be inverse, m to the power 1, L inverse, t to the power minus 1. Done. Next, thermal physics. Temperature is denoted by K. Coefficient of volume expansion is equal to coefficient of linear expansion is equal to coefficient of superficial expansion or surface expansion, or alpha or beta or gamma is equal to delta L by L delta T equal to delta A by A delta T, which is equal to delta V by V delta T. Okay. So the dimension will be K to the power minus 1 since T is in the denominator. Specific heat capacity S. S is Q divided by M delta T. So Q is M to the power 1 L square T to the power minus 2 divided by M to the power 1 K to the power 1. So it will be M goes with M. So M to the power 0 L square T to the power minus 2 and K to the power minus 1. Okay. Next, thermal conductivity K. For deriving the dimension of thermal conductivity K, you will use the equation of H equals to K A delta T divided by L. So arranging this equation as K equals to HL divided by A delta T, where H is the heat current or H is Q divided by not temperature but Q divided by time T. So it will be M L square T to the power minus 3 K to the power 0. Okay. And K will be M L square T to the power minus 3 into L to the power 1 divided by L square K to the power 1. So the overall dimension of K will be M to the power 1 T to the power minus 3 K to the power minus 1 and L to the power 1. Okay, done. Next, Wien's constant. Wien's constant is denoted by the letter B. The dimension of Wien's constant will be equals to the dimension of lambda m T, where T is temperature. Lambda has the dimension of L to the power 1 and T has the dimension of K to the power 1, and time and mass will have the dimension of 0. So L K will be the dimension of Wien's constant. Next, gas constant. Gas constant is denoted by the symbol R. It will have the dimension of PV divided by NT. N is the number of mole, T is the temperature, V is the volume, P is pressure, which is equal to force divided by area. So M to the power 1, L to the power minus 1 and T to the power minus 2. If you can't understand this, P is force by area, which is equal to M L T square T to the power minus 2 divided by L square, which is equal to M L inverse T to the power minus 2. Okay, next. So the answer will be M to the power 1, L to the power 2, T to the power minus 2, M inverse, K inverse. Done. Next, see. Next, Avogadro number is mole inverse. Since it is the number of atom per mole of a substance. Okay, so it will be mole inverse. Boltzmann constant has the dimension of E divided by N into temperature, because energy is denoted by 3 by 2 N kb T. Okay, so it will have the dimension of M to the power 1, L to the power 2, T to the power minus 2 upon mole to the power 1, K to the power 1. It will be M to the power 1, L square, T to the power minus 2, K inverse, mole inverse. Done. Time period t will be t to the power 1, m to the power 0, l to the power 0. Next, frequency will have the dimension of 1 by t, so t to the power minus 1, m to the power 0, l to the power 0. Angular frequency will have t to the power minus 1, l to the power 0, m to the power 0. Force constant k will have a dimension of m to the power 1, l to the power 1, t to the power minus 2, l to the power 1, m to the power 1, l to the power 0, t to the power minus 2. Then next, damping constant. Damping constant in SHM is denoted as Fd equals to minus Bv. So the dimension of B will be equal to a dimension of F divided by V. So m to the power 1, l to the power 1, t to the power minus 2 upon l to the power 1, t to the power minus 1. So l goes with this, and the resultant dimension will be m to the power 1 and l to the power 0 and t to the power minus 1. Okay, next, wavelength will have the dimension of length. Propagation constant k will have the dimension of L inverse. Intensity I will have the dimension of P by A. Power divided by area. So the dimension of power is m to the power 1, l to the power 2 and t to the power of minus 3, and that of area is L square. So the resultant dimension of intensity will be m to the power 1, l to the power 0 and t to the power minus 3. Okay. Next, what are dimensionless quantities? Dimensionless quantities are those quantities which are independent of mass, length, time, etc. So m to the power 0, l to the power 0, t to the power 0, etc. to the power 0, 0, 0. Okay. Next, the dimensionless quantities are angle, solid angle, anything that is inside any mathematical function like sine, cos, tan, exponential, etc. Percentages, efficiency, ratio. Angle and solid angle based question was given in NEET 2022. NEET 2022, there was another question based on the gravitational dimension. Next, if there is one mathematical function like sine A, then A will be a dimensionless quantity. And if there is a mathematical function like e to the power b, then b is dimensionless quantity. Next, strain, specific gravity, phase constant. Strain is delta A by A in bulk modulus, or delta L by L in Young's modulus, or theta in shear modulus. Specific gravity. Specific gravity is the ratio. Phase constant is also a dimensionless quantity as it is present inside any mathematical function like sine, cos, etc. Okay. Next, so all dimension of class 11 are completed. Next video will be on dimension of class 12 quantities. So thanks for watching. Subscribe to Metabolism Wala NEET, and PDF of this lecture is given in description and pinned comment. Thank you.